Hello, chemistry students. Today we're going to be focusing on lesson 7, ions. So if you'll pull out your study guides, we'll be prepared to start having our discussion here. I also recommend you get out your periodic tables. We'll be using those a little bit later for some calculation purposes, as well as getting some information from your tables. All right, so let's get started. All right, you should have your study guides open to lesson 7, ions. All right, let's start out really with a definition. What exactly is an ion? Well, if you look at the types of atoms that we have been focusing on so far this year, they have been electrically neutral. They have the same number of positive charge as negative charge. In other words, the proton and the electron numbers have been the same for these atoms. But an ion is different. An ion is an atom that actually carries a charge or has a charge. And this is formed because atoms will lose or gain electrons during chemical reactions. So what we need to do today is just kind of focus on some basic definitions and some basic principles of ions. Um, when we kind of show you how we would represent an ion um, with its charge, okay, so let's do this. Um, so let's say we have an atom that has a positive charge, like sodium. So we would write the element symbol. So Na, oops, that's awful. I'm gonna erase that, start again. Okay, so let's say we have the element sodium, Na. Okay, sodium, because it is a metal, will often lose electrons. And doing so, it's going to form a positive charge. We always put the positive charge in the upper right-hand corner of the atom, all right? And depending, sometimes there is a number also associated, like let's say magnesium. Magnesium also being a metal, its symbol Mg, will lose electrons, and it will lose actually 2 electrons. And so we're going to put the number 2 that indicates the 2 electron loss, and then the fact that it will be now a positively charged atom, simply because it has more protons in the nucleus than it does have electrons, right? I mean, if you lose negative charge, but you haven't changed the proton number at all, then you're going to have more protons than electrons, and it's got to be positive overall, okay? Well, what about an atom that gains electrons? Something like, let's say, sulfur, for instance. Now, sulfur is a non-metal atom, has a symbol of an S. The sulfur atom, because it's non-metal, they usually gain electrons. In fact, as nonmetals in general, you can assume are going to probably gain electrons. Now, sulfur has a tendency to gain 2 electrons, and so we're going to put the number 2 for the 2 gain of electrons. And because we are gaining more electrons, we're going to have a negatively charged ion or atom. Simply because we're not changing the proton number, we're just adding more electrons to electron shells, and therefore we have more electrons than protons, or in other words, more negative charge than positive charge, okay? Chlorine is another example. Chlorine is a nonmetal, but it only gains 1 electron, so we just leave it as a negative charge, kind of like sodium that loses 1 electron. We just keep it as a plus charge. We don't usually put the 1. You could, I mean, you could put the 1 in front, -1 or +1, which is fine, but we usually leave it off. So here are your negative charged atoms, and here are your positive charged atoms. So do they have specific terminology names? And the answer is yes. So let's look at the definitions or terminology that we use for these two types of ions. So if it is a positive charge atom, then we typically call it a cation, okay? So a cation is a charged atom that has lost one or more electrons to form a positive charged ion. Okay, so again, that example could have been, let's use magnesium, Mg, and it's lost 2 electrons again, so it's a 2 positive charge is our example of a cation. Now, the negative charges are anions. So if you look at the definition, a charged atom that has gained, okay, gained 1 or more electrons to form that negative charge. An example, again, would be sulfur, gaining 2 electrons and therefore has a 2 negative charge. All right, so what if you forget the term cation versus anion? Well, think of this. A cat ion has the word cat in it. And what do we know about cats? What do they have? Well, cats have paws, okay? So cats or cations are positive ions. Remember that, okay? You can use it. It's a very helpful tool. I guarantee you'll never forget that cations are positive, okay? Anions then must be the negative one, or you can think of anions, well, kind of the word anti-anion. Anti is kind of a negative connotation, so be negatively charged. Okay, I know it's kind of silly, but in a way it really does help. So considering using those ideas. Okay. All right, so let's actually give you I don't know, a few more examples of cations and anions. So let's say, let's do some drawing here. Let's start out with some cations. So aluminum is a metal, has a symbol Al, and because it is a metal, it will lose electrons, and typically it loses 3 electrons that contain a positive 3 charge. Another cation would be maybe like zinc. Again, zinc is a metal, and therefore it will lose electrons, 2 of them to be exact, contain a 2 positive charge. And let's use one other. What about copper? Copper's a good one. Copper actually can lose 1 electron and become a positive 1 charge, or copper can also lose 2 electrons to become a positive 2 charge, okay? So how do we determine if it's positive 1 or positive 2 in its name, okay? Well, the symbol, it's really easy because we'll either put copper plus 1 up here or copper plus 2. But in the name, if we were to write out the name copper, okay, copper, then to designate if it's a positive 1 or a positive 2, we're going to use Roman numerals. So if it's a positive 1, we'll put a Roman numeral 1 with parentheses around it, just like that. And we just leave it like that. And that represents that it has a positive 1 charge. If it has a positive 2 charge, then we just copper, right? And then we use a Roman numeral 2, okay, to indicate that. And typically we also put at the end the term ion so that we understand that we are dealing with a copper positive 2 ion. And we can put ion for the copper one here too. All right, so these right here are some examples of cations, okay? Now, anions, okay, the negative charge. Remember, those are usually non-metal. So again, let's indicate these as being metals for the most part, okay? But anions, like oxygen, is a nonmetal, and it's going to lose 2 electrons, so it becomes a -2 charge. Phosphorus is also a nonmetal, and it's going to be a -3, meaning again that it loses, or sorry, gains 3 electrons, just like oxygen gains 2 electrons. Okay. What's another good one? Nitrogen. Nitrogen, nonmetal, it also gains 3 electrons, become 3 negative. Okay, so the point here is that nonmetals, when we're looking at this, nonmetals, so nonmetals are negatively charged, whereas metals are positively charged. Metals lose electrons, nonmetals gain electrons, okay? Hopefully that makes sense. We're gonna spend a lot more time on ions in the coming months, okay? And you'll learn that ions have special names to them and so forth that we'll be learning about, okay? So let's move on to using our periodic table and doing some calculations when it comes to some ions here, okay? All right, so in your study guides, you have a table here, and we're gonna fill out this table using our understanding of atomic structure. We're going to basically look at the number of protons, neutrons, and electrons for these particular ions, okay? See if we can figure some things out. So the first one is a sodium ion. Notice it has a plus charge. So it's going to have a plus 1 charge, ionic charge. Because it's positive, it's going to be a cation. I'm just going to put C for cat ion. You can write it out. And its mass number is 23. If you look at your periodic table, sodium has a proton number of 11. All right, its atomic number is 11. We're not changing the number of protons here. So all of these ions will still have the same usual normal proton number. Its neutrons can be found by still taking the mass number minus the proton number. So that hasn't changed either. Now the electron number, how do we find the electron number? Well, you have to take your electrons that the atom would normally have in a neutral atom and either add more electrons or subtract that based on the ionic charge number. Well, sodium, because it has 11 protons in the nucleus, it also normally has 11 electrons. But because it has an ionic charge of +1, it tells us that we have lost one of these electrons. So that gives us a grand total of 10 electrons in our nucleus, okay? All right, let's go to the next one, chlorine. So chlorine is negative, so it's going to have a -1 charge. It is an anion. You can write out the term anion. It has a mass number of 35. If you look at your periodic table, it will have 17 protons. 35 minus 17 gives us 18 neutrons. And because we are losing, right, losing an electron, or sorry, because we're gaining an electron, we're going to have one more electron than protons. So that's going to give us 18 total electrons. Okay, and we can keep on doing this. Let's look at sulfur. It's got a -2 charge. Actually, I probably really should write the 2 first. I'm not. We don't mark you being wrong if you do that, but traditionally we're going to write the 2 first and then the negative charge. It is an anion. 32 is the mass number. The periodic table says that sulfur has 16 protons. 32 minus 16 essentially gives us 16 neutrons. And since we are gaining 2 electrons, it should have 2 more electrons than protons. So we should have 18 electrons, okay? So what I think you should do is just pause this video for a moment and go through and fill out the rest on your own and see if you can do that, and then come back and let's check out the answers that I have up here, okay? So go ahead and pause for a moment. All right, you should have completed the chart now. So let's check your answers to mine, okay? Make sure you got it. So this should be a 3 positive. It should be a cation. The number of protons should be 13. The number of neutrons should be 14. And the number of electrons should be 10, okay? Because we're losing 3 electrons. We should have 3 less electrons than we have protons, okay? Magnesium is 2 plus. It is a cation. Its proton number is 12. It should have 12 neutrons, and it should have also 10 electrons because we have a positive charge. This should be a negative 3. It is an anion. According to the periodic table, phosphorus has 15 protons. Therefore, it will have 16 neutrons. And since we're gaining 3 electrons, it should have 18 electrons. Okay? Now, with iron here, it has a Roman numeral. Remember, the Roman numeral represents that it is a positive 3 charge. Okay? So I'm going to put 3 positive here. Therefore, it is a cation. Iron has 26 protons in the nucleus, 30 neutrons then. And since we're losing 3 electrons, it should end up having 23 electrons total. Copper, the same way, it has a Roman numeral 2, so it's a positive 2. It is a cation. It has 29 protons. It has 35 neutrons. And because it's lost 2 electrons, it should have 2 less electrons than protons, so it should have a 27 electron number. Okay, so there we have it. These are some basic principles to ions. Just review your notes here. Make sure that you can understand what an ion is, what a cation is, what an anion is. Be able to write the symbols for a positive and negative anion and cation, and be able to determine the proton, neutron, and electron number for these ions. Okay. Other than that, we are done for today. So we will see you until next time. Okay.